Okay, so what I was trying to play around with is to try to understand if Pulumi was actually a better approach to Terraform. For me, the main problems that Terraform had were mostly related to the 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 functionality of modules and how you can actually modularize a project. It's very difficult to actually have like expressive APIs so that you can, for example, set up like a networking module that express how you at your company or your project set up all of the network and then reuse that module in many accounts, for example, prod, dev, CI, whatever that may be. So I was trying to play around and see if with Pulumi I could like accomplish that. I started with like a basic, main.go file that just provisions everything. Here I was trying to like get a grasp of how everything works with Pulumi. So I just put everything in a single main.go to see, just to get a feel of the tool and see like where, especially understand the CLI and the UI and the product that they offer. This is not very interesting. It's just like the setup is, a VPC, traditional one for now, like one public subnet, one private subnet, a Bastion host, the instance, an RDS, an application load balancer, an ECS cluster, an ECS service, and then exporting all the things that I want, right? This is like all of the infrastructure of this like company, right? And just not very reusable, not very everything. You already see like interesting concepts where you can see that here I defined like the EC2 instance. Like you can see that like there's not much exposed, and you have like these top level functions. So it starts to look like a Terraform module, where you like call to something and then you send the parameters that you want. But this is not very like modularized, and it's not the thing that I was hoping for. So I started saying, okay, how can I actually make it so that each, not each layer, but each section of my infrastructure that I want to separate has its own state, its own definition, its own like project. And then how can I make it so that I can reuse what one structure defines into a separate one? How can I make it so that, for example, when I define the network of my like entire system, I can reapply that same network on the dev account, on the CI account, the product account, and whatever that may be? And how can I make it so that I can tweak that without having to copy paste and without having to like guess which parameters go where, right? So
question.
Yeah, go ahead.
Is this procedural or is this declarative?
It's both, actually. So each thing that you declare here feels like procedural because you're just writing it there. But the way that this runs is inside a Pulumi run function. Pulumi calls this entire function, and the output of this is like, what do we need to create? And then goes and actually creates the things. So when you change something here, for example, well, you can easily change the zero block of a VPC. But imagine we're changing like the name of the VPC or something. You will rerun this, and Pulumi will say, oh, the only thing that's changing is the name of the VPC. So it feels procedural in a way because you're looking at code, you're seeing an error here, and you're like seeing all these things. But the actual like the way that this gets applied and the way that this gets tracked over time, that's declarative. Here I'm saying that I want to create a new VPC with a given name. And the nice thing about this is that when Pulumi actually wants to go and create this, if the VPC has a problem, this is the error handling that happens. With Terraform, you have like a generic error for all the resources that failed, and it's all like spread all over the place. Here, for each operation that you try to do, it actually goes and shows you the error. But the way that this happens in the background is not like procedural in that same sense. It is actually generating. I don't know exactly what the name of their internal like definition, the tool that defines all the infra, but it's doing that same thing. So the effects that this has on your infrastructure is the same as if it was declarative.
Yeah, just to double check that I understood this correctly. So you're creating a VPC on line 22.
Yeah.
And that either returns a VPC or an error.
Yep.
So the error, I mean, you can't start creating a security group until you know whether the VPC succeeded creating.
Yeah.
Okay. So from that perspective, it is procedural because you need to have a VPC. The VPC will be created first. None of the other resources will be created. Nothing in this case, maybe it makes sense because everything else depends on the VPC. So that needs to be created first.
Yeah.
But I haven't seen any concurrency, any Go routines that will basically fan out some of these calls, they're all executed one after the other. Is that right?
Yeah, but that's the like kind of more the trickier part, right? So this is all evaluated at runtime, and the way that all these things get linked is done by Pulumi itself. So it's not that the VPC will be created, and until like the VPC is done creating, you will not create the security group. That will only happen if there's a relationship between those two things. There's a relationship
Okay.
between the security group and the VPC. But if there's not, Pulumi will decide on its own how infrastructure will be provisioned. So, for example, if you create a load balancer and an EC2 instance and they have no relationship between each other, those two can happen in parallel. You don't need
I
to worry
see.
about that. Yeah.
So what I'm getting back is basically references to those objects.
Exactly. Yeah.
It's not it's not the output of the execution.
If you want the output of the execution, you have functions that are called apply, because it basically, you can do like vpc.apply, and then inside that function you're going to be like you're going to have all the references of the VPC that you may want, because if you actually need to infer that at that moment, because if not the code won't work, you can actually do that. Yeah. And actually with the latest generic integration of Go, there's a whole like simpler way of doing those things. Yeah.
Got it. That's very helpful.
Yeah, for sure. Nice. So this is not very like different to how you would do, and in fact it might even be worse, because you have things all over the place. You have like this create RDS function, you have all this stuff on a single location. And one thing that you often do with a project like Terraform, with a tool like Terraform Solid, is to separate the state into parts that actually make sense. You don't want a change on the storage like ecosystem, so on a database, to have anything to do with the state that happens on a network, for example. So what you can do is you can create multiple projects, and this could be like all on a monorepo. By the way, like I created separate repos because it was easier for me to like look at it that way. But you can create like your
What's
network.
ninjas? What's ninjas? You have to go back and you have to tell me what is ninjas.
Oh,
I know we're not supposed to talk about that, but I'm
yeah.
curious.
So ninjas is basically a term that we used to use with some friends on a previous company. It's basically like a more fun way of saying like move fast and break nothing. Basically trying to like act like a ninja that just comes in, solves everything. Nobody looks at, like, nobody sees that they exist, and then they just move and everything, and the work got done basically.
I like
So
that.
yeah, the,
That's a
the
very cool
ninja way.
concept.
Yeah.
Okay, cool. So
And we
you're
even
saying
thought about
network.
like building a software consultant company that was called like Ninja Consultancy, but we don't like to be consultants, so that didn't work.
Yeah. I think it'll be very hard to justify like your invoice at the end of the
Yeah.
engagement. Like, what did you do? You don't
That
know
would be
what we
very
did.
confusing.
This is
Yeah.
what you have to pay. Exactly.
For sure. Yeah.
Cool.
Nice. So this is like this project in particular. This is like an API, right? That I use to like test everything, and it's a very interesting API. Like if we look at the code, we're going to see that we return like a name of a ninja on an endpoint. So yeah, that's what we do. That's what we're
Okay.
deploying.
Super useful.
Yeah.
Super useful.
Nice. So what do you typically, what is the first thing that you typically have to provision when you create a new AWS account? For example, the networking. That's the first thing that you need. So you go into your network project, and the network project can be, again, it can be on a monorepo, but it's a Pulumi project, and a Pulumi project basically allows you to separate the state. It allows for other things, but for me, the biggest one is like a project is going to have its own state that you can store like anywhere. You can use the Pulumi service, or you can store it on S3. You can even start up an ECS service that stores data on S3, and you can use like that ECS service to be the one that receives all the network calls and all that stuff. So when you use like the CLI, you just do like Pulumi new project. I don't remember exactly. It's been a while, but in this project, you can see that we have a main.go, which is where we're going to define our Pulumi run function. So this is a declarative part. But you can see that we also have a network library, right? So let's start in the main.go. And here you can see that we're basically in this top level function calling to the network library and saying, hey, in the network library, I want a VPC. I want the VPC to be named this. And these are the properties of the VPC. So a zero block of this, and then the public should have this header and this mask, and the private this mask. This is going to return to me a VPC. Then I want to create a VPC security group, link it to the VPC ID. Then I want an SSH key. This is not a good way of managing it. This is a public SSH, but it's no longer like it's expired, so we can post this.
And also, it's a public one, right? So
It's
even
a
if you
public
store
one.
this
It's
on
fine.
GitHub,
Yeah,
you can access almost
you
anyone's
can actually.
public keys, which are so. I think it's fine.
It's fine.
If it was a private one, I think the conversation would go in a different direction. But public is okay.
Yeah. Nice. So here we create like the Bastion host. We're just using like the EC2 library from Pulumi. So you can see that we imported here. And then this is an interesting part. We call again the network library, and we say, hey, export all of these things, right? We want to export the VPC ID, the zero block, the private subnet IDs, the public subnet IDs, the ID of the Bastion, and the IP of the Bastion, right? So let's go and see how the actual network module works. Like what's interesting about this. So we go in here and we can see that, let me go below. We can see that this is basically the thing that abstracts away how you want to create VPCs, subnets, and all that stuff. So this is what we, for example, we could have like multiple main.go's for different like production. You could have like, for example, imagine like a monorepo. You could have infra, prod, network, which uses the infra network library to create the production networking. Then you could have infra dev network, which uses the infra network library, and they all use the same. Like they all use the same library just to provision the things for each one. Very similar to a Terraform module, but without having to guess the parameters, the export, and all that stuff. So for me, the most interesting part about all of this was this part right here. Since this is a programming language, what I can do is create a function in this same module that gives me a typed output that I can then link from any other required module that needs the state of the network. For example, if you have a storage project where you want to store RDS, I want to create, RDS and those type of things, you're probably going to need a reference to the VPC and to a private subnet. What I can do is I can import the network library, call to the get output function, and received a typed structure where I can select which field I want. And this is all taken care of by this module. When I go and create a platform project where I'm going to deploy like an EKS cluster, if I want to sit that EKS cluster on a specific network, on a VPC and a set of subnets, same thing. I call the get output function. I received a typed structure, and then I just use that type structure to define where I want my cluster to live. So if I move away from here, for example, let's go back to repositories. Let's go back to storage. You're going to be able to see here in the go.mod that I'm basically importing Ninjastructure/network. And in the main.go of storage, this is not yet modularized, I'm getting the output of the network project. And now I'm going to get into a concept of Pulumi in a second. And then I create the RDS cluster, specifying the VPC ID, the VPC seeder, and the private subnets, right? And the way that you can like plug these things together and apply them is actually very simple. And I don't have an example here, unfortunately, but you can actually make sure that the dependencies all meet, like everything is applied correctly, and all the state is basically like created once you want to use like that specific module, that specific library. I didn't do any kind of modularization here because basically you can imagine like if you want to have an opinionated way of provisioning RDS clusters in your company, you can have the storage module inside the storage project that has a create database function which receives the parameters that you accept, and then you can like customize the things that you want in a much easier way. So I've seen a lot of Terraform modules that are like almost Turing complete, like very complicated, very like a lot of conditions everywhere, very hard to test. And there's actually an interesting blog post that I'll search later for like testing with Pulumi. And yeah, with this you can basically generate that kind of workflow in a more like in a familiar way, right? It's just a programming language, and if you specify that you want your data, your instance, for example, to be like high availability or to be like a global Aurora database, I can just create the conditions here and apply the things that I need to apply. Um, so that for me, like this part for me is the biggest, like the biggest win. The fact that I can call a network library to have um, a type structure of what that network library exposes, and I can connect that with the programming language. This for me is like a huge win. This is one of the main reasons that I've seen like issues in Terraform that sometimes are very hard to debug when you're working on multiple modules and you're trying to make changes to the network. You want to like adjust some inbound rules, and then you want to change like where like which subnet, which are the list of subnets that a given database has, like all that set of making sure what this thing exposes, and that gets very complicated. And that's kind of a solved problem in the programming language way. You can just like it's a dependency. I can just update the dependency to the latest release, which contains the new field of the private subnets, and that's it. Like I have that thing ready to go. So this is basically like the main difference between Pulumi and Terraform. Given that it's like a programming language, you can do programming language things. There's a lot of other concepts that I won't get into a lot of detail here because I want to show you like something, some of the things that I've been thinking about on how you could actually use Pulumi in production. The main one I think are the concept of stacks, which is basically like it's used to separate environments. So you could have like a single project with multiple stacks, a production stack, a staging stack, a development stack, and you could do that optionally on different projects. So for example, if you want all your network to look the same, you don't need to do infra prod network. You could just do infra network, create like 3 stacks and apply them all in that specific one. If you want to have separate configurations, you could actually ask, hey, what is the current stack? And just apply the like in the code. You can check, hey, am I in production, do this. I don't like that. I've seen that even applied in Terraform. I think that like misses the declarative part. If you're going to have like environments that are very different, you can still have like an infra folder and then your prod, your dev, your CI, and within there define the things that you want. And the things that you want to be reusable, they can be reusable in a separate library, and they can just be applied, right? So I put the network library inside the network like project, Pulumi project. You don't have to do that. Like you can just create the network library and then refer it to from a specific project, right?
I have one important question to ask. Where is state stored?
There's multiple like state backends that you can have. You can use the Pulumi offering, and they store the state in their infra. There's a UI and there's like a whole integration that you can do. I haven't seen Terraform Cloud. I imagine it's similar, like in concept at least. You could store it on S3 in the same way that you store like the state for a Terraform project. You could actually there's a service that you can deploy on ECS, on EKS even, that can handle all the like conciliation and store the state wherever you want. So for example, if you deploy on EKS, you could store it on a persistent volume and have it live there. You could even deploy like multiple of those services, and the dev one, you have the dev one, for the prod you have the prod one, etc. And I think there's like also like for Google object storage, like basically for each one. Yeah, and in that regard, is very similar to Terraform.
Is there an option where you don't store the state, where the state basically it just figures out what has been deployed and it figures out how to reconcile what you've declared in code versus what is actually running in the provider, whichever you've chosen, in this case, AWS?
I think there was, yeah. If I remember correctly, you could actually just like do like a constant conciliation loop, kind of. Not really a loop, but yeah. Yeah, you could disable it entirely.
Is that something that you've used?
I tested it. I didn't use it for this because I was playing around with this to also show a former coworker how you could leverage this like concept of importing a library. But yeah, I haven't, not extensively, not in production.
So, in the context of this project, where did you choose to store the state?
I really wanted to try the Pulumi service because one of the fun things that it has is that you kind of don't have to do anything, and there's like a free tier that it's like really generous for now, at least. And Pulumi has a lot of like other products that they were kind of interesting. So yeah, I decided to use. Basically, I was trying to play around also with other platform as a service things. Pulumi does have like a way of not necessarily being like a full end-to-end platform, but it's coming very close to it. So yeah, I use their offering. Yeah.
How did that work?
So there's a UI. Let's go to Pulumi.com maybe. It has a few nice things. For example, one of the things that I like is that you can visualize everything very nicely. So let me see if I have any projects. Yeah. So you have, for example, network production. This is like one of the stacks. Here you have like all the output, right? You have like each deployment that you do is going to trigger one. Then you have like the whole resources map, and you can see it as a graph, and you can see like all the things that get plugged. And the state itself is stored like here. Each time you do a deployment, it shows you like the output of how it differ and all that stuff, and you don't have to worry about it. You just do a Pulumi login, and that's it. For me, the interesting part there was thinking a little bit. Let me go here. Thinking a little bit how you can actually like apply these type of things in production. And there's two main ways that I found and play around with them a little bit. The first one is the one that everybody probably knows, and it's like the pipeline one, or the traditional one, we can say. You can do everything like imperatively, kind of from a CI perspective. So you have, let's say that you have your repository where you have like, you can have a Pulumi stack. A Pulumi stack is like a project, or like the actual infrastructure that you want to deploy. So the main.go would be, you have the Pulumi library, and here I'm using like Argo CD because we're at Dagger and we're using Argo CD here. And then like we can have Dagger modules that orchestrate things, right? So orchestrate execution of code. In this traditional setup, you could have your repository where you have an infraprod network, Pulumi stack, an infraprod storage, Pulumi stack, infraprod security, for example, and then an infraprod. In our case, we're using like EKS, and we commonly put like the dates as part of the folder. So you could have like one for the current cluster that you have running, or you could have even n, so one per each cluster you want to create. And each of these Pulumi stacks can use a library that defines the things that we traditionally do. So, for example, we deploy EKS cluster at Dagger in a specific way, right? We want to use like Argo CD. We want to have a few other things, like core things installed on top of it. So we could define like an infra platform, Pulumi library, that defines the creation of the EKS cluster and the installation of Argo CD. Everything could be like modularized. You could have the version, you could have all that stuff. And then you could refer to that infra platform library from the EKS like 2024, 2025, 2026, and so forth. This would be like a traditional approach where you have like a Dagger module that is in charge of doing like the app and the preview. If we go back here, I did actually write a blog post that talks about this kind of setup. And this is like the infrastructure as code module, right? That defines the app and the preview comments, and it allows you to post a comment to GitHub. I think I have a PR with GitLab as well. The not so great thing about this is that you have all the credentials and all that stuff on your CI environment. So you're going to need to be making sure that you have that secure. But if you want to take the GitOps approach, you could. This is more in depth to what we do at Dagger. So there's going to be a few things that are very specific to how we are. I'm not going to say how we run applications because that might change, but how we are thinking about running applications here. In the GitOps approach, you would basically have an initial like bedrock, which is a name I stole from you, Gerhard, where you basically create the things that you need in order to start mounting all the other infrastructure on top. So you would create like the network, which is like still uses like the infra network library. You would create the platform one, the EKS cluster in question. If you have more than one, you can create more than one. This can simply be applied from a developer machine that has like it's an administrator and is in charge of creating like the initial setup. It has the credentials, it has all the things that it needs. And then all of the additional infrastructure that is used to run your company could happen in a GitOps way using Pulumi, but managed by Kubernetes' controllers and the conciliation loop. So imagine that you have this Kubernetes cluster. In this Kubernetes cluster, we use Argo, right? And we have like our core applications here on top. So we have like an API, we have Daggerverse, we have a few other things. And then on the bottom, we have the infrastructure, right? We have the storage, the security, the network, like all the components that we want to deploy, right? This resource defines a stack. A stack is this concept from Pulumi that basically says, hey, like this is the things that I want to deploy. Like my production storage stack is 2 RDS clusters, etc. This stack is a CRD deployed on Kubernetes. And in the Kubernetes cluster, you have to have the Pulumi operator installed, which is basically going to watch the stacks that you have. Each stack is going to define the repository and the location where you know your stack is specified, and it's going to basically make sure that every single time that changes, it applies that infrastructure, and that like conciliation loop is basically that GitOps approach is taken care of by the Pulumi operator itself. So this is going to watch like the infra prod storage, security, and network, and like once you create the initial setup, you have basically like that constant conciliation loop. There's a few things that are unclear about these approaches. I haven't tested them. I'm just thinking, you know, what are the ways to take these things to production? The main like concern that I have with this one is the ability to preview the changes that you want to make on a PR. That for me is like incredibly helpful. You could use like a read-only credential and set it on the CI. You could do some more fancy stuff where you like instead of using like a traditional CI runner, you define like a Kubernetes job that gets executed and that posts the comment to the preview, but it won't necessarily be like nicely integrated with like a check and all that stuff. Here we know how it works. It's all in the CI, right? So yeah, this would be like the more GitOps approach where you are constantly watching for the changes that you want to make for your infrastructure, and then just everything happens, right? If you want to migrate, for example, let's say that you are creating a new EKS cluster because the old one it's old, it's on life support, and you want to migrate things over. That's okay. You can just set up everything on the new one. Even the Pulumi operator, it's going to watch the same stacks, and one of them will win. Like either this one or the other one. Like there won't be any like problems when applying. If you don't define a state or a way for these to lock resources, you might have problems. I guess I'm not sure. Again, haven't tested it. But you could like, if I'm deploying things on S3, it's going to grab like a lock, and then it's going to just start doing the apply. Or you could even like disable the Pulumi operator on the existing cluster, deploy the new one, and then have that be the one that watches for all the changes, right? Again, I wrote some stuff down on the things that are like good, bad, etc. It is an unknown approach for me, not for everybody, I guess. The Pulumi operator has been around for a while. I haven't done this type of, connect Argo so that Argo watches the stacks themselves. So if I ever want to add a new stack or that type of thing, Argo manages those resources, and then Pulumi manages the actual work that needs to happen in order for a piece of infrastructure to be provisioned, deleted, changed, and etc.
This is really, really good. I love the diagrams. Conceptually, everything makes a lot of sense. And I'm very keen to go to a state where we're trying this in practice and seeing how well it works. There's a couple of things which I'm seeing, which I'm not sure how well they will work because there's only so far that you can imagine, but I'm excited to try it out. And that's the takeaway. Let's do this.
Nice.
Matias is a professional trail runner, and we work together on Dagger's infrastructure. We both share the same passion for things done well. If you enjoy this content and want to be part of the whole experience, go to makeitwork.tv.